today's Technical Corner, we're going to be talking about something just a little bit different, virtual machining technology. Paul, let's start off with the very basics. Why would an engineer need this virtual technology?
Yeah, sure. Well, first of all, thank you for having us here this morning, Joe. So virtual machine technology, why invest in it? Well, if we look at a workshop and we look at the investment that we put into our machine tools, the last thing we want is for it to have a crash. So what we have to think about at these points are machine downtime, the damage to the machine, damage to the components, loss of man hours, all of these things, they accumulate, and then we have to think about, okay, how often is this happening a year? Or maybe how often is it happening generally?
Sure.
And I think when we think of all of these things, when we talk about a return of investment, I think virtual machine technology and collision checking is very important to us.
But it's more than just collision avoidance, isn't it?
Absolutely, yeah. So virtual machine technology in Tebis is, as we see it, different to some other providers. We see this as being a special for Tebis and a benefit to it. And what we do is we use the virtual machine technology at 3 stages of our process: planning, programming, and verification. So if we talk about planning to start with, why the need for this? Okay, so we're given a component to machine. What machine is it going to fit on? What tool lengths do I need to use? Am I going to use the optimum tilt direction angles? What's the optimal position on the machine bed? Have I got any other components I need to be aware of for checking? And by doing these checks first, we can see, okay, how is the process going to work? We can get it clear.
So the engineer would tell Tebis what tools you're proposing to use, and that would do it for you from then on.
Absolutely. In Tebis we have 5 libraries which we use. The cutting tool library, the machine libraries, and then we have the automation libraries for features, cycles for standardized machining processes and processes. But ultimately, yeah, we've got all of these libraries set up for you to reflect the workshop activity to standardize this process. So when we talk about cutting tools, we'll go into the cutting tool library. And you have the option then to decide which tool is going to work for you.
Sure, so you said 3 elements. There's planning, there's programming, and what was the third?
Verification. So maybe if I just take a step back just a moment just to talk about the programming side of it, because this is quite important. With the virtual machine technology, we actually incorporate all of the machine limits, rotational, linear, into the virtual machine itself. And this is really important when we're programming. So when we actually create a toolpath, or whether we've got one predefined, Tebis uses those limits and the head geometry to actually create the toolpath. So if I'm trying to do something that's not going to happen in reality, Tebis won't let me produce that toolpath.
And how about cycle time calculation? Is that accurate?
Yeah, so actually with the virtual machine technology that we use, cycle time can be 90-95% accurate. And the reason for that is because when we measure the machine and we're putting all the macros that we talked about into this software, is that we take into consideration the machine look ahead, maybe the rapid rates of the machine. So as long as the machinist is going to operate at 100% feed rate as to the programming conditions, then yeah, the calculation is accurate, which is really important for programming, planning.
Yeah, and costing as well. What machines can you use this virtual machining on?
So actually all machines. So it could be standard milling machine, vertical milling machine, 5-axis milling machines. Could be a lathe with multiple turrets. It could be a robot. So we can simulate all of these kinematics. And you can, whichever machine you've got, we can provide. So,
okay. Obviously, you guys you're heavily involved in mould and die. That some of these machines are huge. In fact, some have more than one head. So, what would happen if you've gone from, say, a roughing head to a 5-axis finishing head? How did Tebis, how does that work?
It's a really good point. Yeah. So,
thank you.
Yeah, that's a really good point. So, yeah, in Tebis, we're able to simulate multiple heads with virtual machines. So, just like a tool change simulation, we're actually able to simulate a machine head change, which is maybe quite different again to other software, because other software maybe need 3 virtual machines to do this, where Tebis we can do it all in one. Then we have things like we check macros on the machine. Now the macros could be something that's controller defined, like a tool change. Could be that maybe we have something historical in that maybe the machinist has actually created a program or a macro himself that he likes to use. Well, actually we can incorporate that into the virtual machine too, and we can utilize it. And then we have the check-in between toolpaths at the start and end. So normally this is where the machine controller would take over and try and get from point A to point B in its own way, which is dangerous. So yeah, Tebis controls all of these points and collision checks against them for safety.
Yeah, so is that classed as verification?
Absolutely, yeah. And then we have verification on the toolpath as well, just to expand on it, which is what we would expect.
And if it's wrong?
If it's wrong, we're an integrated system. And because we're an integrated system, we're using the virtual machine technology as we program, as I said earlier. So we can make a change directly into the software.
All within Tebis for that going in and out?
Absolutely, rather than have maybe another system which we've exported to and then have to go back. So these are all the benefits of
And finally, Tebis. How about multiple setups?
This is a really good subject. It's actually a very nice piece of software that Tebis have produced. So if we have a scenario maybe that we have components being produced by maybe separate programmers. All of these programmers are actually linked with all of these standardized libraries which I talked to you earlier about. Now what Tebis allows us to do is if we have a large machine, we can position multiple parts on the bed and actually utilize the full machine capacity. Or it could be a small machine with a tombstone setup. And it doesn't matter if we're machining set up one of one job, set up two of a different job. We're able to position all of these things on the machine bed, and we link Tebis automatically links all of these operations together and optimizes the tool changes and tilt directions for you. So yeah, maximizing the machine.
So seems an obvious question, but you'd recommend this? So you'd recommend going into the virtual machine technology?
Absolutely, absolutely. And the virtual machine technology, as I said to you, will pay for itself when we think about all of the subjects that I talked to you, we mentioned at the very start. And as a benefit as well, the virtual machine technology, what we do as a service is that we'll come in, we'll measure the machine. We also then, as I said, we take all the macros from the machine that you want and we incorporate all this in. And we link the post-processor to it. So the virtual machine and the post-processor are talking to each other all the time. And yeah, the output is good. So yeah.
It sounds good. So there we are, virtual machine technology from Tebis.